is what we all know, especially about the reflections. Lateral reflections increase the source width of musical, and ceiling reflections, early reflections improve the speech clarity. Michael Barron has given lots of explanation and lots of papers on this. And the point was that can we experiment it? That was the design reverberation time with my calculations, and this is actual measured values. And what we tried is we put the screen, these ceiling reflections, to mask the ceiling reflections, we put the screen of half of the auditorium, and further measurements were taken. So this is the SPL level, and we can find that by reducing the reflections or by neglecting the reflections, the SPL is not that much affected. That means what results we are getting in the next slide, that is not because of the gap of signal to noise ratio. The signal to noise ratio is constant, and these are the results. This is without the air conditioning on, that is the noise criterion NC30. If you find that space transmission index STI figures, side A is with reflections and side B is without reflections, and the difference is quite noticeable. This is with some additional noise. Still the reflection difference is there significantly, and it is increased. So once again we can say these reflections are definitely very helpful, but unfortunately in most of the cases or most of the designs that I have seen in our part, that reflections are missing in design. More focus is given on the absorption, maybe because absorption calculations are simple, absorption data is widely available or widely forced by different means. It is more discussed, maybe because of in architectural colleges and schools they discuss and they taught more about the absorption calculations. Maybe it is difficult to merge the reflections with the demand of architects' interior decoration schemes, and maybe somewhat more dependent on electronic reinforcement.